Yes. Good afternoon, students. So it's my pleasure to introduce this circular linked list and their operations. So I would like to share my screen. So hope my screen is visible to you. So this is a classroom discussion topic on the week 9 lecture 1 operations on circular linked list. So the summary of the previous CDT, if you see that here, in the previous CDT we had a discussion on operations of single linked list like creation, searching, insertion, deletion, and traversal and reversing of a single linked list. So these are the different operations we have studied on single linked list. Now the objectives of this today's session is that we are going to discuss about the circular linked list, insertion operation, and the deletion operation. Fine. The lecture outcome is that after completion of this particular CDT, students can able to implement insertion and deletion operations on circular linked list. So what is the circular linked list? So the one difference between single linked list and circular linked list is that the last node of the single linked list which contains a null in the link field. So it is replaced with a pointer which points to the first node of the list. That is the only thing we have. So we can have circular single linked list as well as circular double linked list. So we traverse a circular single linked list until we reach the same node where we started that. So the circular single linked list has no beginning and no ending because we have the circular manner we are taking here. So start node or head node where we are pointing to that is the beginning and ending point we can take it as. There is no null value present in the next part of the any nodes in the circular linked list. So this is an example. If you see that here in this circular linked list, so this is the one data item. Next is the link field. So it's pointing to the next node two, and next three it is pointing to that. Now the last node link field, next link field is pointing to the first node. Okay. So and this is the head node which is pointing to the first node of the list. So this is a circular single linked list. We can call it as CLL. We can call it as fine. So what are the applications of this circular single linked list? If you see that circular linked lists are mostly used in task maintenance in operating systems. Okay, so maintenance of the tasks in operating system, we can make use of a circular linked list. So there are many other applications where circular linked lists are being used in computer science, including browser surfing, where a record of pages visited in the past by the user is maintained in the form of a circular linked list and can be accessed again on clicking the previous button. So these are the operations which we are going to see within the circular single linked list. Fine. So struct node we are defining same as similar to this what we can call it as a single linked list. Int data struct node star next struct node star head which is equal to initially null we will keep, and these are the beginning insert, last insert, random insert, and void begin delete, void last delete, random delete, and display and search. And this is the main void main function. So we are creating a menu with these options. Okay, so we have enter the option based on that choice. So we are calling the respective function. We are calling that begin. If choice is equal to 1, we are calling begin insert, 2 last insert, and 3 begin delete, and 4 last delete, like that. This is a menu driven program we are writing to implement all the operations in a circular single linked list. Fine. So once we have this, so now begin insert. If you take it as here, we are taking a struct node star ptr and star temp int item. So we are creating a memory for this ptr struct node malloc size of struct node. So if ptr is equal to null, then overflow, else what we are doing here is that enter the node data. We are reading the data and the PTR arrow data equal to item. And if head is equal to null, then we are putting that head is equal to PTR. PTR next is equal to head. Else, this is very important. If we have only one node, okay, so this is the first node we are creating, and this uh, data item value is 1, and this is the link field, and this link field we are again giving to this same node. So what we are calling it as, this is the head we are putting here. Okay, so fine. So this is what we are going to do here basically. So this is the PTR node. Fine. So like this here we are creating the first node we are creating and pointing to the same node. Else if head is not equal to null, that means from second node onwards, temp is equal to head, while temp arrow next not equal to head, temp equal to temp arrow next. So we are, so PTR arrow next is equal to head, and then temp arrow next is equal to PTR, head is equal to PTR. So this is what how the node will be inserted into a single circular single linked list. So if you want to insert the node at the last, then we have to create the node and allocate the memory. And if PTR is null, overflow, else enter the data, and PTR arrow data equal to item. If head is equal to null, head is equal to PTR, PTR arrow next equal to head. Else we have to traverse that. Temp equal to head, temp arrow next not equal to head, temp equal to temp arrow next. Temp arrow next is equal to PTR, PTR arrow next equal to head. This is what we are doing in the last node insertion. Fine. So this is a display here. Struct node start PTR, PTR equal to head. If head is equal to null, printf nothing to print. Else, if printing the values here, PTR arrow next not equal to head, we are printing that PTR arrow data. PTR equal to PTR arrow next. So this is what we are going to do. The display operation. Fine. So now coming to this, this is the reflection spot here. So what are the different operations we can perform on single linked list, circular single linked list? So you have to answer this question. If you are not able to answer this question, please watch the video from the beginning. Lecture outcomes are revisited here. After completion of this session, students will be able to implement the operations of single linked list, circular single linked list basically. So these are the operations we can define on circular